real exam questions. This is question 24 and it deals with yield lines and slab design. Prove the 30-45-60 rule for the transfer of loads to the supports by means of yield lines. Use a right-angle triangle slab with one side simply supported and the other side partially fixed. Take the two most important assumptions. The slab has a side length of A. We start with the axis of rotation, which is at the supports, the two supports. We know that the yield lines start where two axes of rotation crosses under an angle alpha, because we do not know what the angle will be because of the different conditions of the support fixation at this side. The bending moment is then situated at a distance S1 and a distance S2. So this line, the length of this line is S1 and the length of this line is S2, because this is 45 degrees. So we have S1 and S2, and here also S1 and S2. We must not forget the negative bending moment, which is this yield line, but it's partially fixed, so it means it is an unknown factor m times beta times m. So first we must say that A, that is S1 plus S2, of course, and the parameter that we will use to optimize the yield line is of course alpha. So, but alpha itself is difficult in the equation, so we'll take the tangents of alpha and call it x, but the tangents of alpha is then easily S1 over S2 is the tangents of alpha and is x. So we'll try to express everything in function of x and then optimize for x. The work done by the external forces is the load that we have times, for this triangle, we have A times S1 divided by 2, and for the other triangle, it's A times S2 divided by 2, and then multiplied by the mean deflection, which is there, the maximum deflection delta, and the mean deflection for triangles is delta over 3. And this is then Q8 squared over 6. Of course, it is the total, or the slab is comprised out of only triangles, so you can just take the total load, which is Q8 squared over 2, and then times the mean deflection delta over 3. So you can put this directly instead of doing it this way. The work done by the internal forces or internal bending moments is then m for this line projected to this axis of rotation, so it's m times s2, and the angle of rotation is of course delta divided by s1. Same happens with this yield line projected to this axis of rotation. It gives you this. And then the negative bending moment is beta m projected to this axis of rotation. So it's beta m times A, and the angle of rotation is delta over S1. Now, this is S. We must make E equal to D and take M out of it, but the parameter to optimize, we have taken X. So you will see that A over S1 can be written at S1 plus S2 divided by S1. So this can be written at 1 plus S2 over S1, and this is 1 plus 1 over X, because X is S1 over S2. Now we see here S1 over S2, S1 over S2, so this x and 1 over x, and this is 1 plus 1 over x. So we can rewrite D in function of our parameter x. E is equal to D, so the bending moment M is a function of x and beta, of course. The maximum bending moment now for x is when the first derivative from M is 0. It means that this must be valid. So you solve this equation, you got x is the square root of 1 plus beta. What does that mean? When you have a situation hinged, then you will see that beta, because there is no bending moment at support, that beta must be 0. So for beta equal to 0, x is 1, and x is the tangents of alpha, so it means that alpha is 45 degrees. So for a fixed situation of an hinged situation, alpha is 45 degrees. For an hinged fixed situation, just when the fixation is maximum, that means that beta is 2, because the negative bending moment is 2 times the positive bending moment. Then for beta 2, x will be the square root of 3, and when this is the square root of 3, alpha is then 60 degrees. And for the 30 degrees, it's of course 90 means 60 is 30 degrees. So you see that the 30, 45, 60 rule can be has been proven. The assumptions that we've made here, and we must not forget it, is that there is no interference of supports in the vicinity, because you only took a triangle piece of slab. So that's an assumption, and the yield line pattern is correct, but more or less correct. We know that in the corner of the slab, you have some positive bending moments that can have an influence on the exact pattern of the yield lines. So, but in general, you can say that the yield lines are more or less correct and that there is no interference of supports in the vicinity. Only under those conditions, the 30, 45, 60% rule can be applied.